All right, in class we've been talking about transformations of quadratics. We learned that to translate something to the left or to the right, we need to add or subtract the number inside parentheses, and it's opposite what we would think. So to translate something to the left, we're actually going to add a number to our x, and to translate something to the right, we're going to subtract a number. To translate up or down, we're going to add to translate up and subtract to translate down. So that's straightforward. But horizontal transformations are backwards and always inside parentheses. To reflect something vertically, we have the negative sign outside the parentheses or without parentheses. And to reflect something horizontally, we have the negative side inside the parentheses. Um, because a parabola, which is the graph of a quadratic, is symmetric, the reflection horizontally actually maps itself onto itself. So that's why it doesn't look any different from the parent function of f of x equals x squared. So we're going to take that and we're going to add on to it, and we're going to talk about dilations, or how to actually change the shape of our parabola by making it thinner or wider. And we want to recall that vertical transformations are the easy ones, but horizontal ones are tricky. We find them inside parentheses and they're opposite what we'd expect. So if this is our parent function, y equals x squared, and we wanted to dilate it or make it thinner, then we double the y values if the transformation or the coefficient is not inside parentheses. That will change our y values, and in this case it's going to double them. Had this been a 3, for example, it would triple the y values. A 4, a 5, again, quadruple, quintuple the values, depending on whatever the coefficient is. However, if we have that same, almost that same transformation, except now it's inside parentheses, then it affects our x values and it does the opposite. So instead of doubling our x values, it's actually going to cut them in half. If this were a 3, it would cut them in thirds. If it were a 4, it would cut it into quarters. So it affects the x values and it does it opposite from what we would think. Similarly, if we are having our y values, if the coefficient is 1/2, then we're going to half our y values as long as we don't have parentheses. But again, if we have that same thing, but it's inside parentheses, we're going to do the opposite to our x's. So instead of taking half, we're going to double or multiply our x values by 2. And that's how we'll generate the new points of our quadratics. We'll be doing a lot of practice with this, but again, these dilation rules stay the same for all kinds of functions, not just quadratics. And speaking of other functions, we're going to be talking about absolute value functions today. So to be able to do an absolute value function, the first thing you have to remember is the parent function of a line, y equals x. This, of course, goes through the origin with a slope of 1. So we rise 1, run 1, rise 1, run 1, or drop down 1 and go to the left 1. So if you recall, an absolute value makes everything positive. So if, let's say, our x value is negative, like -1, the absolute value of -1 is going to be positive. So instead of going down 1 to -1, we're going to go up 1. So that's how we get this V shape for an absolute value function. So absolute values are always in this V shape. And what's happening is we're taking any of our negative part of our line and we're just reflecting it vertically across the x-axis. You could also think of it, it's symmetric. We could also think that we're going to reflect our line, y equals x, whatever this is, across the y-axis. So absolute value functions are V's, and they're essentially just reflections of the parent function, of the parent linear function, I should say. And again, all the same transformation rules apply here. Shifting left or right, we're going to add or subtract a number within parentheses. In this case, our grouping symbol is the absolute value sign. To translate something up or down, we're going to add or subtract a number outside. And to dilate, we'll either have a coefficient outside the absolute value symbol or inside the absolute value symbol. And again, negatives, of course, will reflect it across the x or the y-axis horizontally or vertically. So all those same rules still apply. We're going to do a lot of practice with this in class. If you have any questions, please come next class with them. Thanks.